Hello everyone. So in this video, we'll solve this problem based on the concepts of polynomial functions. So in this problem, for each graph, we have to answer these 5 questions. And we are given 2 graphs, A and B. So let's start with the graph A. So we'll start with the first question. So as per the first question, state whether the corresponding function has even degree or odd degree. So for that, we'll have to analyze the given graph. The given graph is the red curve. So as you can see, the red curve goes across the x-axis as we go from left to right. So the curve starts in quadrant 2, then crosses the x-axis and ends up in quadrant 4. This type of graph is for an odd degree function. So the answer for the first part is that this is an odd degree function. So this is a very important concept you need to understand and memorize. Now we can answer the second part. State whether the leading coefficient is positive or negative. Now in this case, the graph is going down from left to right across the x-axis. So the leading coefficient is negative. So if the graph had been going up from left to right, then the leading coefficient would be positive. But in this case, it's sloping down from left to right across the x-axis. So that's why the leading coefficient is negative. So next we have to write the domain and range for this graph. Now, as we know, the domain is for the x values. Now this graph spans the whole x-axis. So it starts at the extreme left end of the x-axis, goes all the way across the x-axis and continues all the way to the right side of the x-axis. So this graph spans the whole x-axis. So the domain for this graph in the interval notation can be written as negative infinity to positive infinity. So that's the domain. And now we have to write the range. So the range is for y values. So we can see this graph spans the whole y-axis. So on the top side, so it starts from the extreme top and it keeps going down and covers the whole y-axis. So that's why the range is also negative infinity to positive infinity. So there is no break or any restriction on the domain and range. In the next part, we have to describe the end behavior. Now, end behavior can be explained in 2 ways. One is in terms of the quadrants. So if we have to describe the end behavior in terms of quadrants, so in this case, the graph starts from quadrant 2 on the left side and it ends in quadrant 4. So the quadrant behavior can be described as quadrant 2 to quadrant 4. Now end behavior can also be described in terms of the infinity notation. So for that, so as x approaches negative infinity, so we have to analyze the end behavior on both the extreme left and the extreme right. So on the extreme left, as we go to the left side, the graph keeps going up. So y approaches, sorry, I missed the x. So as x approaches negative infinity, y approaches positive infinity because the graph keeps going up on the left side. Now on the right side, as x approaches positive infinity. On the right side, it's positive infinity because the numbers are positive numbers. So y approaches. Now as we go on the right side, the graph keeps going down. So y approaches negative infinity. So that's the end behavior in terms of the x and the y values. So now we can answer the last part for the first graph. So identify the type of symmetry. Now there are 2 types of symmetries, point symmetry and line symmetry. So this graph has point symmetry because if we rotate this graph about the origin 180 degrees, then the graph will get the same shape. So if I rotate this graph about the origin 180 degrees, we will get the same graph. So that's why this graph has point symmetry. So this is a very important concept you need to understand and memorize. So now we can analyze the second graph. So let's start with the first question. So state whether the corresponding function has even degree or odd degree. The graph is starting on the left side above the x-axis in quadrant 2 and it ends up above the x-axis in quadrant 1. So the graph is starting and ending on the same side of the x-axis. That's why this is an even degree function. So in the previous graph, the graph was crossing the x-axis and ended on opposite sides of the x-axis. So that's why it was an odd degree function. So now we can answer the second question. So state whether the leading coefficient is positive or negative. Now in this case, the graph starts above the x-axis and ends above the x-axis. So it starts in quadrant 2 and ends in quadrant 1. So therefore this graph has a positive leading coefficient. So if this function had negative leading coefficient, then both ends of the graph would be below the x-axis. Now we can answer the third part, the domain and range. Now this graph spans the whole x-axis. It starts on the extreme left and it goes all the way to the extreme right of the x-axis. So it keeps getting wider and spans the whole x-axis. So the domain for this graph will be negative infinity to positive infinity. So there is no break in the graph along the x-axis. Now for the range, so the graph doesn't span the whole y-axis. The graph doesn't go below the x-axis along the y-axis. So that means there is a restriction on the graph along the y-axis. So here the graph only goes above 0. It doesn't go below 0 along the y-axis. So the range will be, so here 0 is included, so we use the square brackets, 0 to positive infinity. So that's the range of this graph. And now we can describe its end behavior. So in terms of quadrants, the end behavior can be described as quadrant 2 to quadrant 1, because the graph starts from quadrant 2, it comes down and then it bounces back up and ends up in quadrant 1. Now if we have to describe the end behavior in terms of x and y values, so as x approaches negative infinity, so on the extreme left, the graph is going up. So that means the graph is approaching positive infinity on the left side. So y approaches positive infinity. Now on the extreme right, as x approaches positive infinity, so as we go along the curve to the right side, the graph keeps going up. That means y also approaches positive infinity. So in this case, the graph is heading upward at both ends of the x-axis. Now we can answer the last part of this problem. So identify the type of symmetry. This graph does not have point symmetry because if I rotate this graph 180 degrees about the origin, it'll end up like an downward opening parabola kind of shape. So we won't get the same graph. But this graph has line symmetry. Why? Because the y-axis divides this graph into two parts which are overlapping parts or which are a mirror image of each other. So that's why this graph has line symmetry. So there's a very important concept you need to understand and memorize. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.